Okay, in class we've been talking about Gregor Mendel and his experiments with pea plants in the monastery and the garden that he kept there. And we're going to be using Punnett squares today to look at how we can determine the probability that different traits will be passed on to the offspring. Before we go ahead and start working through some of those, we need to talk about genotype and phenotype. Genotype is an organism's genetic makeup. It's how the actual genes combine in an organism. The phenotype is the physical expression of those genes and what the organism actually looks like. So the genotype is the genetic makeup and the phenotype is what it looks like. Now, there's two forms of a trait. There's dominant and recessive. We see 5 of the 7 things that Mendel observed about pea plants here, and you'll notice that with the dominant form of each of the traits, we use a capital letter to express that. So there's 3 different ways that we can write out a genotype. The first one would be big R, big R. I'm going to just go ahead and stick with the seed shape because we've been talking about it in class. So we're going to focus right there. So genotype could be big R, big R. This would be what we would call pure. Okay, so the phenotype, what does it look like? Well, it's round. Okay, because you have a capital letter, that's the dominant form of the trait, and it's what's going to show up. Then we can have big R, little r, and this is called a hybrid. So if we have a hybrid genotype, it's still going to be round because you still have the dominant form of the trait. Okay, you don't really care about the recessive. It's hidden. It fades into the background. Dominant one is the one that shows up. Then we can have the recessive form, little r, and the recessive form of the seed shape is wrinkled. So first thing that Mendel does is he takes a plant that has round seeds and he crosses it with one that has wrinkled seeds. Now he doesn't know what the genotypes are. He just knows that it's a plant that has round seeds and one that has wrinkled. So when we cross them, this is what you get, all hybrids. Okay, so in the offspring, the genotype and the phenotype, let's see what we get. Well, we get one genotype, and it is hybrid. It's a 4 out of 4 chance, so 100% chance. And then our phenotype, well, what does big R, little r look like? Well, it's round. Again, 100% chance. So then he takes the offspring plants, so maybe he takes these two, and he crosses them together. So now they've got round seeds crossed with round seeds. And here's the genotypes. Okay, and when we cross them, here's what we get. Now remember, if you have a capital letter, you should write it first. Okay, so the possible genotypes that we get are big R, and that's a 1 out of 4 chance. You can get big R, that's a 2 out of 4 chance. And you can get little r, that's a 1 out of 4 chance. Now, the phenotypes, here and here, those are all round. Okay, so you get a 75% chance of having plants that are round, even though these are both hybrids. Now, the cool thing is that you also have a chance of getting a plant that has wrinkled seeds, and that's a 1 out of 4 chance. So because both of these parents are hybrids, they're carriers for the recessive form of the trait, and it actually could show up in the offspring. So, like maybe we're not talking about pea plants, but we're talking about people. You know, dark eyes are dominant and light eyes are recessive. So let's say that, you know, this was brown eyes and this was brown eyes. So both of your parents could have brown eyes, but they could be carriers for blue eyes, and that would have a 25% chance in showing up in the offspring. So maybe you're the only person in your family that has blue eyes and your brothers and sisters and your parents don't. So then Mendel takes a pea plant that's wrinkled and he crosses it with another one, and this is pretty easy. It's wrinkled for all of them, and the genotype's the same. It's recessive, and the phenotype was wrinkled. Okay, so that one's pretty easy. That's not bad. Now, a lot of the times you don't know the genotype. You just know what it looks like. You know the phenotype. So we're going to do an example here. Let's say that you have a plant and the peas are round. They're not wrinkled. You know that it has to have at least that one capital letter to make it dominant, and we have to cross it with a wrinkled one. And the reason that you have to cross it with a wrinkled one is because if you have something, in this case it's a pea plant, that shows the recessive form of the trait, in this case it's wrinkled, if it is the recessive form of the trait, this is the only thing the genotype could be. It has to be little r. So I'm going to write that here, and I'm going to write the round on the side there. Okay, I don't know what this is yet. Okay, so I crossed these two together, and I want to know what the genotype is right here. Okay, but I know what the phenotype is because after I cross them together, I get two plants that are round, and I get two that are wrinkled. Okay, so what does this genotype have to be over here? Go ahead and work it out. Okay, so I'll do the top part. So this would be round and round, okay? So I'm good there. Got my two round. How do I get two wrinkled here? Okay, what does this have to be? Well, it has to be the recessive form of the trait to give me the two wrinkled. Okay, so I've got two genotypes, and I've got two phenotypes. It's a 50% chance for each.